This is Physics 1 course. In this video I'm going to solve a problem using all three Newton's laws. A box with mass of 100 kilograms is on the surface of a cart with mass of 200 kilograms. So this is the box, this is the cart. The box is pulled by a rope. This is the rope, and it slightly slides on the cart. That means there is not enough friction between the cart and the box. Acceleration of the box is 2 meters per second square, and of the cart is 1 meters per second square. Now there are two questions. Find the friction force between the cart and the box. 2. Find the force exerted by the rope on the box. First, let's take every information that is given to us. So the first is mass of 100 kilogram is m1. So m1, this is 100 kilograms. And mass of the cart is 200 kilograms. So this is the mass of the cart. M2 is 200 kilograms. The box is pulled by a rope and slightly slides. Acceleration of the box is 2 meters per second square. So acceleration of the box, so 1 refers to the box. Acceleration of the box is 2 meters per second square. And acceleration of the cart is 1 meters per second square. So A2 is 1 meters per second square. Find the friction. So friction we usually show with F mu. So we want that. Find the force exerted by the rope. That means the F. So find F. The very first thing to do when we are going to use Newton's laws is to draw all the forces on the objects. So let's say this is the box. The first force to write is usually gravity, and the direction is downward. Then the surface of the cart exerts a normal force on the box toward up. That's why the box doesn't fall down. And there is a force by the rope, F, and there is a friction force that is against the direction of motion exerted by the cart, and that is the F mu that we want to find. So that is all the forces on the cart, on the box. Now let's do it. Let's find all the forces on the cart as well. So this was M1 actually. So now again the force is M2G, Newton's gravitational force, a normal force from the surface of the ground. So let's call this N1, this is N2. So N2 is exerted by the ground on the cart. N1 is exerted by the cart to the box. Now there is another force which is using Newton's third law. We know that when the cart exerts a force on the box exerts an equal force to the cart in opposite direction. So therefore, using Newton's third law, we get this force. So these are all the forces on the cart, and these are all the forces on the box. Let's first draw a reference frame, a coordinate system. Let's say this is X, this is Y. In Y direction, there is no motion, so neither box nor the cart move upward or downward. That means acceleration in that direction is 0. Therefore, the net force in Y direction is always 0. That means N1 equals M1G and N2 equals M2G. But that doesn't help a lot solving the two questions, so it was just for our own information. Let's move on to the net force in the x direction. So we have two objects, therefore we have two sets of equations. For the box, we have F minus F mu equals, so since our x direction is this in this direction, then F is positive and F mu is negative, equals M1, mass of the box, times A1. So A1 is given here, M1 is given there. So let's do it. 200. 2 times 100, 200. Kilogram meters per second square. This is just 1 Newton. Now for the other object, which is the cart, the net force is F mu. This time it's in the positive x direction, so the sign is positive, equals mass of the object, M2, A2. It's equal to 200 times 1, 200 kilogram meters per second square. So we basically answered the first question, find the friction force. This is the friction force. So that's it. To solve the other question, find the force exerted by the rope on the box, that means find F, we just need to use the other set of equation. So F minus F mu, this one, equals 200 newtons, and therefore F equals F mu plus 200 newtons. And from this we know F mu is 200, so 200 newtons plus 200 newtons equals 400 newtons, and that's it for the second question.
Thanks for watching. Please subscribe to support my channel. If you have any question or comment, please send me an email at open.physics.project@gmail.com. Thank you.